So, as always, the code for this question will be in the description, but if you want the explanation, you can continue watching this video. So, see, the thing is, this question is easy. This is the last question for this day. For me to record. So, I'll go over this thing quickly. And the first question I failed in, the first question for which I had to look at the editorial. So, basically, whatever I'm explaining to you has been explained in the editorial, but it's my job to explain to you every question in Codeforces. But before you get into the solution, let's look at what the problem is. What is the problem? They'll give you this first. Not they will give you. Take A, B. Given A, what you can do is break it down completely, essentially everything. The point is, if there is a 1 somewhere, then the surrounding like sides, all the rows and the columns will become 1. Basically, that's the gist of it. Or function, yeah, everything. You break it down completely. If there is a 1, it will completely become 1. So, if there is a 1 in a singular point, the surrounding elements completely diagonal, not diagonal, the column and the rows, the column, basically this row and this column will become 1. Everything in that till however long the matrix is will become 1. As you can see here. So given this 1 is there, so this will become 1. So we'll get this. So the thing is, they will give us B. Sometimes it may not be right. So you need to find out first things first whether we can make an A from it, and if we can, what is that A? And if there are any possible answers, then you can print any of them. So we'll look at this thing like this. Okay, so we'll be given B, to find A, whether A is possible or not, and if it is, how do we get this and what it is? How do we solve this thing? See, the thing is, I kept thinking, looking at the A, the ones. 1, right? This 1, how do we use this 1? Because that is the point where we need to write 1. So I focused on ones in this B. Given this B, I was focusing on ones, but that is the wrong approach to follow. To focus on zeros, because ones, there are plenty of ones here, right? There are plenty of ones in this array, because in this list, in this matrix, because this is the singular point which caused all these ones, but we can't find that thing. So it's a foolish thing to search for the singular point, the ground 0 1. Instead we can focus on zeros, right? So instead of imagine, let's switch your thinking. Instead of imagining from A to B, let's think, can we convert B from B to A? Which means that the similar thing applies but reverse. So in this case, if it was 1, then the row and the column will become 1, right? In this case, if it is 0, the row and the column will become zeros. So you can write down B in such a way. You see that this thing works perfectly. 0, everything is 0. 0, everything is 0. Since there is no 0 here corresponding anywhere, so this will stay on. If you look at it, actually works pretty fine. So you can use that concept. Instead of going from A to B, just think about going from B to A, first things first. So construct A from B, not construct A. Use the property that I told you. First things first is if 0 is a 0, all the columns and rows should become 0. Then you'll get something. Now the point is it possible? First thing, you got something, but in order to really know that this is the A or this B can get an A, we need to check whether this will again go back to B, right? First, if you can go here and you can go back, then good. If you can come here but you can't go back, that means it's not even possible. So basically what we're supposed to do is, given B, construct A, construct some other 2D matrix or something. So given B, construct A. Think. Given B, construct some matrix in order to check whether this matrix is A, which means that there exists a A for B. Convert this A back to B. So in this case, you got this. Now the same thing. You go through each and every one, and if you find a 1, just transform it. So basically, from B, you'll get one matrix using for every 0, you'll turn every row and column to 0. This matrix, you'll take every 1 and you'll turn the row and columns to 1. The resulting matrix that you get, if it is equals to B, that means this is A, you print this and you print yes. If this is not equal to this, no, that's it. That is the answer. My work is done today. Please leave me. Thanks.